Hi, everyone. Thank you for joining us. My name is Yochai West from Ephoca. I'll be our moderator for our session today. Many of you have come by our booth. We've had a chance to speak to you guys individually, but I thought it'd be great to get here in a single session some of the most refined people that we have in the industry speaking about something that I think is pretty much a challenge for most of you all today, is how do we take great ideas of products, how to implement those products, how to put them all together and enjoy, how do I understand how this is gonna work for me, right? You go by, you see a shiny new product, you're like, wow, that's great. But then, the anxiety starts seeping in. What is this? How am I gonna get this installed? How is this the right thing for me? There's so many options. What are the costs around it? And we would like to kind of get this session for you guys to understand and break that down for you a little bit more. So we're gonna ask our panel over here a number of questions that we most commonly get in the industry. And of course, if there are any other questions or things that we didn't cover, then we would love to have you guys step up to the mic and inside as well. Ask any questions, sing us a song, whatever you'd like. All right? So we're gonna start first by introducing our esteemed panel. I'm gonna start here on my left, Tal.
Hello, everybody. My name is Tal Eyal. I'm president of First Service Project Management, which is division of First Service Residential, the largest management company in New York City. And I will speak a little bit about the challenge that as a board, as a management we have, and what's the opportunities that we have as well.
Excellent. Now we'll move on to Brandon.
Hi, Brendan Casey, Vice President of Sales with Ephoca, based here in New York City and focused on cold climate air source heat pumps, our unique cold climate air source heat pumps that we offer.
Good afternoon, I'm Tom Esposito from VRF Solutions. We are a design, build, decarbonization mechanical contracting firm. We're in the business of getting fossil fuels out of your building, replacing your boilers, cooling towers, through all air conditioners, and any other non-electric heating and cooling system out, and replacing it with high-efficiency heating and cooling via heat pump technology.
Excellent. So there you have it. Our panel, we have property management, we have product, we have implementation, and we're hoping to bring that all together to give you a sort of a rounded answer to many of the questions that are plaguing us throughout our transformation into the world of electrification and decarbonization. So I'll start with the first one, which is, what are some of the challenges related to heating and air conditioning? Again, on a global challenge, not necessarily on on what exists or what doesn't exist. And what we'll do is we'll work through the panel here to give their perspectives, one from a product standpoint, from an installation standpoint, and from the property management itself. So let's start with Brandon. What are the challenges you're seeing today in heating and air conditioning?
Okay, yes, it's almost hard to believe only a few years ago, we were still building new buildings with gas-fired steam systems. A lot has changed in, let's say, the last 20 years, where now we are no longer, the city is mandated to no longer have combustion in new buildings and for older buildings to retrofit. This presents a lot of challenges. VRF systems, variable refrigerant flow or mini splits, is where I really got my start in the heat pumps, working with heat pumps. But there's a lot of challenges, especially in occupied buildings, to retrofit with that type of equipment, because there's a lot of intrusion into the apartments, into people's spaces to try to make that work. This is where I made that jump over to working with Ephoca, my current company and the sponsor of our event here today, where we have products that are much easier to retrofit, especially in an occupied building, and much more easily in a building that already has a through-the-wall opening, whether it's a through-the-wall AC sleeve or what's called a PTAC, basically any type of a unit that already has a hole through the wall going to the outside. We have a product that is able to convert your building to electrification, to be able to reduce your operating costs, to improve the comfort of everybody's home, and to eliminate that on-site combustion, which is what the city would like everybody to do. And yes, and we have a booth over there after this presentation. If you're interested, we have some of our products on display for you to see.
Now, Brendan, I wanted to ask you, I mean, heat pumps, we're saying the word heat pumps. Not everybody knows what a heat pump is. So I just want to make sure that's clear because the name is very deceiving. Heat pumps, you would think, oh, does that do air conditioning as well? And if you can just give us a quick little analogy or,
Sure.
3,000 feet explanation of what a heat pump is and why is it so interesting?
Sure. No, when people think of using electricity for heating, they're often thinking about what we refer to as resistance heat, which is the type of heat that you get from a hairdryer or a toaster. It uses a lot of energy, as people who are aware. It's not a good way to heat your home. It would cost a lot of money because it's just not efficient. A heat pump is more like your refrigerator. Instead of how can I best describe it? What we say is it moves heat. Instead of trying to create heat out of nothing, it takes the heat outside, even on, let's say, a 0-degree day, there's heat in the air that it's able to move inside. I don't want to get too technical on it, but the long story short is moving heat from outside to in is much more efficient than just trying to create heat with a resistance heater. And it's basically the same technology that you have in your refrigerator, of course, in your air conditioner as well. Just think of it as, the same product, but that can operate in either direction. It's almost like a refrigerator that you can make the inside cold or you can make the inside hot.
Excellent thing. So going back to the question, the big challenges in heating and air conditioning, we heard from Brendan from the product perspective, but I'd like to hear now from Tom, who's going to tell us a little bit about from the installation, from the installer, what are those challenges?
Thank you. We walk hundreds of buildings every year, and every building is unique. When we walk into a building, we're looking to see what is the degree of difficulty, right? And when I say degree of difficulty is, are there openings for the Ephoca units? Are there places to put outdoor condensing units in case a building wants to go with mini splits or VRFs? Is there enough electric power in the building, enough capacity in the building? Also, many of these buildings also wanting to get rid of the boilers so they can take advantage of the clean heat program, they also need hot water. So a lot of times the challenge is not can you do the project, it's educating the board so that they're comfortable and they can help make the shareholders comfortable. I mean, I'm on many nights where I'm on a Zoom meeting and I've got 70 or 80 faces of shareholders on 3 screens trying to answer questions to educate. The second biggest challenge I see is once you do get into the building, it's access. It's arranging with every apartment owner to get in for that specific amount of time to do the initial work, which is usually the rough-in work, and then to be able to get back into the apartment to either do the start up or finish up. It's usually access, organizing people's schedules. If we're piping the inside of a building, then you have to get everybody home on the same day on the A line or the B line or the C line. A lot of the jobs we're trying to do now is bringing that infrastructure on the outside of the building. So it's less work in the apartment and that infrastructure could be tied to the outside. When it comes to Ephoca units, the challenge is getting in there, opening up the existing hole, which is the PTAC hole or the air conditioning hole. And in many cases, you don't know what the condition of that opening is. So at that point, it could trigger either it can be installed very quickly by just removing the existing equipment, or you have to do some modification and air sealing. So there are challenges, but every one of them has been overcome across the hundreds of jobs we've done to decarbonize and electrify these buildings.
Yeah, thanks, Tom. And I think the education part is really important because we have people coming over the booth and saying, oh, which one is right for me? And many times it takes us to ask the right questions, so then you sort of rediscover some of the things that you have. Is it necessarily this configuration or that configuration the best way to do it? Many times it's just coming, seeing, and being able to prescribe the right thing, then helping you to sell that appropriately to the people who need to make that decision. So on this final note of this question of what are the challenges of air conditioning and heating, I'd like to call upon Tal to speak of this on the perspective from the property management side.
So let's face it. We have old building, we have a new building. We have a building with very tall, they have short. We have a different system. We have a building that's working on steam, on one pipe, two pipe system. We have a hydraulic system. We have a VRF system. We have et cetera, et cetera. So there is a lot of system, and really us as the management, as a project management, is try to find the right solution for right building. And it's not so easy. You need to first, what's the situation of finance? What's the condition of the existing system? For instance, is a boiler that you installed 2 years ago? Oh, this is difficult to sell project if you just installed boilers 2 years ago and you spend $750,000 on the boilers. Do you have air condition, or are you using AC window units? So we need to ask a lot of questions. We need to know the building. We need to know the characteristic of the building. You know, there's a board that as soon as there is a new regulation, they're jumping, they're moving, and they are very exciting. There is a board that takes much longer in order to lead them and to make them realize that we need to move forward. Now, we're talking right now really what activates everything. It's Local 97, the Climate Mobilization Act. And we're going to start to see fine in 2025, May 2025. And this is definitely will accelerate. In 2030, there will be another benchmark, and a lot of buildings that did not pay fine in 2025 will pay in 2030. So us, as a management, we need to look and see where is the number, what's the impact, how are we going to educate the board, as Tom said, how are we going to help the board, not only the board, the residents, to move forward? What is the right solution for the individual building? And believe it or not, there is no one solution. Me and Tom recently finished one project that we took relative small building, and it used to be on one pipe system, and we converted to a VRF solution. So this building no longer use oil, no longer has issue with window units. We really convert this building, what I will call to economy building, to luxurious building, because they have their control on an app, on a phone, and they can control what the temperature they want during the summer or during the winter. So it's complicated, it's not easy. We as on the management, on project management, need to do a lot of work first to realize what we believe is the right direction for the building, and then help the board and the residents to move forward to the right direction.
Excellent, thank you, Ted. I just wanted to know, as a raise of hands, who here is being driven by local law 97 penalties to find a solution? Can I just get a raise of hands? Okay, interesting, okay. There's some people who are here from the stick model, right? They're really, someone's coming at it with a stick. And there are also a lot of people here with the carrot model. They just want the world to be a better place and, get a better system out there. And, but I think both of the models come together, sometimes beyond our control. So just good for me to get a pulse on that. Now let's move over to the part of the session where we start talking solutions. And ours isn't necessarily always the solution. But I like to start with baby steps. Many people ask us, what's the best practice for implementing? And many times we say, take one unit, put it into a certain area, get people to feel it, understand it, love it, and then work. You don't have to, sell everything in one shot to the entire board, transform the entire building. There's some gradual steps. But before we get to those, I'd like to start with sort of like an incremental upgrade. And we want to talk about just the simple upgrades that we can do as sort of an idea, just to start wrapping our heads around some of the ideas that we can start with. So I'd like to start with Brendan, if you talk a little bit about what's exactly out there at the moment that we can start dipping our toes in.
Sure, sure. Yeah, I'm sure most people coming here today are very involved in the decision making in their buildings and are open to see what new products are out there. You know, there's a whole list. The city of New York provides a whole list of upgrades that buildings are able to make to improve the efficiency of their building. And I think Yochai just said something very important, that, you know, converting an entire building is a very, very big step. It's to completely change everything. And it's something most boards would want to be more, you know, cautious in their decision making. So exactly that. You know, upgrading your existing system is still a very good idea. Look at what you have, how you can improve the efficiency of it. While at the same time, look at all of the different options out there, such as heat pumps and, you know, larger efficiency measures. But yeah, just basically improving the controls in your building will certainly help you improve your building.
So let's take boilers, for example, right? We have people who are getting new boilers. And then when you speak to them, it's a new boiler for them, but the boiler itself is actually refurbished or used. So you have to look out for that, because just because you got a new boiler doesn't mean it's going to last you longer than that. But also, once you get a boiler, for example, like what's still there? What is still there that you can maybe do a little bit better with?
Right, right. No, that's sort of the you know, all buildings, older buildings, need to look at not only replacing that boiler or whatever other central system they have, but also the infrastructure in the building. The piping throughout the building is also sometimes 80 years old, and there could be a big expense off in the future. So, you know, this is all part of a big process of making a decision of what's best for your building.
Right. When
Look at everything.
Excellent. So when I was speaking to people in the booth, one of the big things that I hear is about individualized, you know, control of the temperature in your building. Like, why are we, it's in 2024, right? And we all still have to agree on certain times of heat, certain times of cool, when everything else, we're just so advanced. You know, why is that still a thing? I think is the question that people still have. So thinking a little bit about that, the autonomy of being able to have really that in even in your own, within your own apartment, and of course within your building as well. Think about the amount of scuffles that will reduce from your heads as far as when the heating season and the shoulder seasons and everything in between. So just anything else from the panel? Just wanted to talk about, again, simple upgrades. You're thinking about the ideas of like incremental versus overhauls.
Yeah, first, I want to say, in the hundreds or thousands of buildings I've walked in the last 8 years, almost nobody is comfortable. I've been in buildings from NYCHA buildings to the apartment below Howard Stern, and there's not one of them that was really comfortable, except when you walk into a building that's got a heat pump and you walk in and you feel that different feel. In heating mode, it's a nice warm heat, but it's not dry. In AC mode, you do not have that cold, clammy feeling, because it is matching the latent load and it's pulling that moisture out of the air. Many of my clients that used to run their air conditioning on 68 degrees to remove that moisture are now at 72 degrees and they're extremely comfortable. So from a comfort standpoint, we are way behind the curve in the greatest city in the world to go in and have an uncomfortable apartment or an uncomfortable lobby. And as you were talking before about doing things incrementally, sometimes a project for a building is do your lobby with a specific piece of equipment, either a heat pump or some of the Ephoca units or a variety of other newer technologies, so that the building can get a sense of what this can be. Or put a unit in a community room or in the playroom or in the gym or in the management office, just so people can get a little bit of a sense of what this unit can do, how it sounds. You can see, feel, and touch it. You know, challenges are across the board here. But people need to see that there's a better way of living and a more comfortable way of living in New York City with the newer technology.
I can think of a few reasons why the apartment under Howard Stern would be uncomfortable, and it's not air conditioning.
It's not just the
air conditioning.
temperature.
But yes, Tal. Please.
So I want to take it from different direction. All of us planning. If you have a kids, young kids, you're planning for college one day. If you are one day you would like to retire, you need to plan for retirement. If you want to get married, you need to start to plan how you pay for this. The same thing you need to look on apartment building. You need to figure out what is the next, where are we going, how much it will cost me, do I have enough reserve? Is my equipment is the right equipment? Do I'm going to get a fine in 2025 or 2030? When is my boiler is going to die? You need really to start to take and to start to have a planner and to try to have a direction. And if you don't, there is a lot of individuals that can help you with the planning. One of the things I always recommend when you're going to electrification, which is a nice word, it's scary. It's like surgery. Again, when you're going to surgery, you're going to get a second opinion. You better get a second opinion if you didn't. The same thing, you want really to debate, you want to feel it. Perhaps have a unit or two sample, try it unlimited. So in my mind, the preparation, it's important, the planning is important, and eventually, the idea that if you are on the board of directors, so it's not only you're convinced on your following board member, but the entire resident need to realize that this is the planning, that's the direction we are, and you need to be part of the mobilization that help the building to go to the next stage. So planning, it's a crucial, and it takes time, and it takes a lot of effort.
Excellent. Thank you. Anything else? Okay. So I'd just like to move it one more step forward from the incremental small upgrades to a larger upgrade and some of the expectations that we can have from anything from reducing common charges and the like. Brendan, can you tell us a little bit about that?
Sure. I mentioned previously, sometimes people just make small changes to their building, but sometimes we go into a building and the boiler, they tell us their boiler won't make it another winter. And we have options available, options that could be implemented very quickly if needed. That in addition to just being, a complete retrofit of the building, there's a lot more benefits that come with it. The ability to heat or cool your apartment anytime that you wish. The ability to no longer have a common charge for heating. To just eliminate that from your common charge and have every tenant be responsible to pay for whatever heat or air conditioning they're using throughout the year. And a lot of times it's a more efficient heating system. So not only do you reduce your common charge, but each resident's annual cost will go down as well. So there's reasons to go out there and just, jump into the water and do a complete retrofit of a building. It's a type of thing that can go slow if that's what the board and that's what everyone wishes for. But certainly the opportunity to really improve the quality of your building quickly is also out there today.
Yeah, I'm going to piggyback on Brendan. All the projects that we do, except for a handful of years, are full building electrification projects, where we're going in and either putting in a large VRF system, an individual heat pump system, the Ephoca units to replace old PTACs. Most of our projects, about 30% of them require an electrical upgrade, which is within our contract. Many times we have to provide steel and dunnage on the roof and bring that power to the roof to handle the condenser farm. Many of the buildings are requesting now that they want electrical upgrades in the apartments as well, so that the condenser or the heat pump system could be tied directly to their bill, because they want to pay their fair share of heating and cooling, while maybe some of the people on the upper stories, have their windows open because they can't control the heat. It's not their fault, but it is common if you look around the buildings now, anything 5 to 10 stories, the upper 2 floors have 20 to 40% of their windows open from November until April. And that's money flying right out the window. But what's also happening is at the high pressure point of the building, because of stack effect, cold air is coming in on the first 2 floors. So the people on the first 2 floors are a little too cold. People in the middle are comfortable, and the people on the upper floors have their windows open. If you give everybody a thermostat where they can actually live at a temperature that they're comfortable with, they close all the windows. It's a big, big issue in the city because that is a behavioral change. Many people I see, they come home, it's too hot, the window goes open, and that's the way the window stays all winter while it's freezing out. You can be comfortable with your own thermostat. Most projects, when there's enough evidence out there and enough examples of full building electrification projects, that you could confidently step into that with the right type of contractor to do a full electrification project and be extremely happy at the end. And when I say full electrification, heat pumps for each apartment, whichever brand or whatever model you're looking at, as long as they're efficient and they meet the clean heat programs, incentive thresholds. A domestic hot water heat plant, so that is the only thing that usually stays on the common charges. But now instead of using it through your boiler, you're doing a heat pump hot water system, trying to provide the plugs behind the stoves for people that want to upgrade to induction stoves later on. And like I said, as well as the electrical panel upgrade in their apartments. I cannot tell you how many apartments I'm walking in, there's still knob and tube, there's the stuff arcing in the wall. This is stuff that needs to be upgraded in New York City. But from a bigger perspective, these complete building projects are extremely successful. People are very comfortable, they save money, and they don't have an oil bill anymore, and their common charges have gone down.
So I'm not sure how many of you don't know, but in 2025, New York City will not allow for developers to use gas, natural gas, for heating or cooking in their building. Also, they pass a new regulation that in May 25, that every building that using natural gas, if it's a stove or if it's dryers, they will require to have a sensor to monitor, like smoke detector will be gas detectors. Why I'm speaking right now about this issue? Because the city is trying to discourage the use of gas. It's clear cut. I believe that as we're getting to 25, between Local 97 and the new regulation on the gas, it will be even more clear where we're going. So I'm really trying to encourage everybody to realize, to see where is the horizons, and see what is the right implication for your building, what's work for you, and how to do that, and how to state the job, how to work on the finance, what is the right product for the individual building. It's need to make economic sense. So as much as it's important to do the right by the environment and by to try to combat climate change, it's need to if you are a board member, you're running the corporation of the company of the buildings, and it's need to be economic sense. So it's everything need to tie to economics together with the physical condition, together with the new regulation that we are going to observe.
Excellent, thank you. So Tom mentioned the idea of cultural change. There's the age-old question of what's better, to leave my air conditioning on all day when I'm not home, or turn it off and, put it back on, towards midday, end of the day. And the answer to that is that the technology has changed. I mean, my mother she lived me well. She has a fridge that is older than me. And she says, they don't make them like they used to. It's true, they don't, but there's technology called inverter technology, which has basically changed that concept entirely, that you don't have to ramp up and ramp down every time. You don't have to turn off your air conditioning necessarily and turn it back on. The technology allows you to create sort of this steady stream, or the steady one wins the race, if anyone Aesop Fable fans. So I just want to go a little bit more, Brandon, into some of the technology differences. Can you break down for us a little bit, and then the team, of course, to chime in on, we throw out a lot of acronyms here, we throw out a lot of terms. VRF, not VRF Solutions, but VRF as the technology versus heat pumps, or Pete tax, or this, that, and the other. Can you just walk us through some of those things, so at least we come out of here, some folks here jotting down notes will know a little bit better about some of these acronyms that people are throwing out. We'll be a little bit smarter next time.
Sure. All of these products, whether what's called VRF or what's called a mini split or what's called a heat pump, at the end of the day, it all goes back to my example before of a refrigerator. It's a compressor, a motor that moves a liquid through a set of pipes. On one side, it goes from a liquid to a gas. On the other side, it goes from a gas to a liquid. And each time, whether, like hairspray, be feeling cold, when that gas goes from a liquid into a gas, it gets cold, and that would be your air conditioning. On the other side of it, when it goes from a gas back to a liquid, that's like that outdoor unit of an air conditioning system, or the other side of a window air conditioner. It's the foundation of this type of heating and air conditioning. It's the type of heating and air conditioning that 98% of the world uses. The United States just happened to stick with the original technology from the 1800s up until about 15 years ago, when all of a sudden we started looking at what we have and saying, this is destroying the environment. We're ridiculously uncomfortable. We're paying, thousands, sometimes millions of dollars for apartments, and we have this thing in the window with an accordion on each side, and we hear the sirens and everything coming in. With the products that we have available today, all of that goes away. All of the noise from outside goes away. All of the dirt that's coming in through those, bad openings in the exterior that have a lot of infiltration, that goes away. You eliminate all of that, and now you have a comfortable home, almost like living inside of a refrigerator. But you don't want to do that because that's you'd run out of air. But you get the idea, though. It's you now are completely sealing up your apartment to the outside, and this system is able to provide your heating and air conditioning. The one other thing, it was said before, inverter. The thing about an inverter, older systems, they would turn on and you would have your lights dim. Because the system just turns on and draws full power, runs for 5 minutes, and then turns off and your lights go bright again. All of the equipment that we're talking about today is variable speed. It's like the cruise control on a car. You go in, you turn on your air conditioning or heating to full power, and the system just slowly starts ramping up. And it just keeps going until it gets about to where it needs to be. And then throughout the day, it just, sun's coming in the window, your air conditioning just goes up a little bit just to counter that additional heat. Then all of a sudden it's in the shade again. It just goes slowly down. So you never hear it come on and off. You never have that dimming of the lights. It's just for some magical reason, all of a sudden you're comfortable every day.
And we're not even calling it AI. I mean, it's just,
It's not, we don't even have
you
to
don't even
say
have to say
AI.
AI. Whatever that means.
Whatever that is.
Excellent.
To answer one of your questions from before, you made a statement about should we keep our unit on or off? With the old style air conditioners, because they burn so much electricity, a lot of people turned them off because it was costly to run during the day. But with a heat pump, because it costs so little to run these, my advice to my clients is if you like it at 70 degrees and you feel compelled to back off the heat, put it up to 75 when you leave for the day, and when you come home, you can lower the temperature. It does not take very long to recover from 70 to 75 to 70. But if you turn that heat pump off or that AC off and leave the apartment on a 90-degree day and come back, it's going to take hours and hours and hours for that apartment to come to temperature, not because of the air temperature, it's because of the physical temperature of all the physical surfaces. So this desk would be 90 degrees. The chair would be 90 degrees. Even if my air conditioning was cranking for the first 10 minutes when I came home, it's going to take hours for the table to get cool. It's going to take hours for the chair to get cool. So I would not shut these systems off, whether they're in heating and cooling. I would just have a setback, like also if 70 degrees is your comfortable place in the winter, set it back to 65 when you leave for work. When you come home, have your temperature kick on 10 minutes before you go in. All the thermostats are programmable or Wi-Fi controlled, and just have the heat come on 10 minutes before you come in, and you'll be very comfortable. I see there's a question. There's a microphone right there.
Sorry.
Hi. I apologize if you covered this already, but with heat pumps, would people's electric bills skyrocket?
No, they would go up, of course, because you'd be using your own electric with the heat pump to heat the apartment. But I see an average of about $1.54 per square foot annually to heat and cool the apartments. Now, it depends on what temperature you like. Are you a person that likes to keep your heat on with the windows open? Depending on the type of building you have, single pane windows, do you use curtains? You know, I see a lot of people that have single pane windows. Their apartments are comfortable because, like grandma, they shut the curtains at night and it retains that heat. A lot of buildings have done window upgrades, which is a big help. A lot of buildings also have done some air sealing, which is also a very effective measure. But you know, from a heat pump perspective, your bill should not skyrocket. It's going to be higher, but it shouldn't skyrocket.
Are you familiar with like an average percentage? I mean, this was a concern from our board and owners. So if I could give them a ballpark number, it would help our discussion.
So in 2011, I had a house that I own 100% that basically tree fell and destroyed it. And I had to rebuild it as a two-family house. And on a time, 2011, it was a long time ago, I made a decision I'm going to go VRF system. And I was nervous because I'm renting the apartment. What happened if, one, the tenant's coming to me and said, the system is not working, it's too cold or too hot in the summer, they will leave. Or second thing, if they're paying too much, it will be, again, I cannot afford it. It was never any issue. So I don't know the statistic, the number exactly, but I can tell you as a user, not as I'm not selling anything here. It's worked for me very well.
Okay.
Yeah, I think there was a report by NYSERDA that if you have a steam building, it's about a 30% savings, just dollars year over year, converting from a steam system to a heat pump system. So 30% savings. And going along with what Tom said, in addition, if you're moving that from a common charge to each person paying their own bills, you still have that savings. It's still, overall, you're spending less money on heating. Some newer buildings where they have hot water or chilled water going throughout the building, some of them are pretty efficient systems. So then it's not really as much of a big energy savings as it's just reducing the common charges, reducing the maintenance that's required in your building.
So to get the owners on the same page, we would kind of, because they pay their own electric bills, but but our overall gas bill would go down. We'd have to make that reflect in their common
every
charges
building is different.
so that it offsets their electric bill. I mean, that's like one way to
every building is different in the city, and really, like, every building is different. Every time I visit a building, there's something different. So yeah, we look at each situation. We can give you a good ballpark after a brief walkthrough of your building of what the opportunity is by looking at the infrastructure, looking at the existing equipment. But the steam one has a lot more research on it. And the NYSERDA, with the laboratory in Colorado, they're all like, there's a lot of research on that saying you'll save a lot of money getting rid of steam.
Yeah. Okay, thank you.
You're welcome.
Just to give you
By the way, it's not only money, but it's quality of life, especially if you don't have central cooling system.
So regarding quality of life, what I've been told, and I have houses that are oil-fired, baseboard heating, hot water. Converted one of them to gas. Okay, that took a while, worked. When I wanted to go to mini split systems, what a lot of people told me, and so I haven't done it yet, is that because it's an air system, once it turns off, the place cools down quickly. So there's a lot of fluctuation in the apparent warmth of the home, whereas water, especially in the old heavy steel baseboards, but the water in the copper tubing keeps the air warm longer. So it's a more gradual transition. Can you speak to that?
From what we have seen, listen, if you got a big cast iron radiator sitting in there, it's going to retain the heat. There's no doubt. But we don't have any of the issues because we have our clients maintain their temperature. Right? If you set your apartment at 70 degrees, it's going to be 70 degrees. Now, 70 degrees in New York City for most people in the wintertime is freezing because they've been in buildings that are 100 degrees. And I mean, I can't tell you how many times we've walked buildings and you knock on the door and they're like, hold on, I got to, it's the middle of the day and I got to throw pants on because they're running around in their skivvies because it is so hot in the apartment. And you walk in and every window is open. So it all really depends on, how are you, how are you living? It's everybody's building is like that. I mean, it's kind of frightening to see, how much energy we waste and it's just going out the window. And I put in heat pump systems after having clients, talking to a board for 2 years. And then all of a sudden you get a call, hey, my apartment's not that warm. Well, we wanted to be really energy efficient and I just shut it off. It's 10 degrees outside. Of course your apartment's going to be cold. You shut off your heat. What most people don't realize, when you transform from a boiler building to a heat pump building, you're going from a high energy building, right, where all the walls are hot because you got steam risers and water pipes. Everything is hot. If you thermal image that building, it looks like it's on fire. When you go to a heat pump building, you're going to a low energy building. So that's why it's important when we do look at these buildings, we always work with the board and say, look, after we put in the heat pumps, do a good air sealing program. Get a good weatherization. Weatherization and a little bit of air sealing goes a long way, especially in a heat pump project, so that you can reduce any of the stack effect that is created and you stop that unwanted cold air from leaking into the building. Even just basic weather stripping around your front doors. I mean, there's so many buildings we go, you could slide a small child under the front door and they wonder why the lobby is cold. Because you got a giant gap there, or their automatic doors open at the exact same time. The first job I did in the city up on 100 Central Park West, both doors opened in the front of the building and both doors opened in the back of the building. In less than 2 minutes, every drop of heat was evacuated out of the space. And it's just timing the doors. So one door closes when the other door is opening. Little things you do with a heat pump conversion can make a big difference.
I have 2 questions. Okay, one question is the VRF system. What kind of incentive do you have? I know right now the split unit with the Con Edison, they basically, I have a small building, 16 unit only. So I install each unit 2 split unit, and it cost me 0. Okay, I don't pay anything. I installed 34 unit. Okay, one is 9,000 BTU, the other 12,000 BTU. Okay, that's one question. But the other one is, right now, since they're one apartment, 2 unit, so I suggest them to do, when you go to sleep, turn on the bedroom unit. If you don't use it, don't turn on. But based on your suggestion you had before, you better turn on the whole day. Is it how you save the energy?
I would not turn off the systems. I would just lower the temperature. I would set it on your programmable thermostat. If you leave at 8 o'clock in the morning, you could have that thing set back at 7:30 in the morning down to 65, and half an hour before you come through the door, that system can kick back on to 70. So when you walk in, you're comfortable.
So you suggest during the winter time, always on, but different temperature.
Because it modulates, there's 2,600 steps between 0 and 100% usage in a heat pump.
Okay.
2,600 steps between 100 and 0.
Okay.
So it comes on and can gradually come on very incrementally. So
Okay.
for instance, you walk into your apartment, right? That electric eye is going to sense you walk in, right? It's going to make sure that it's at the temperature you want. 10 people walk into that apartment. Inside of 10 minutes, the return air is going to sense that there's a greater load in the apartment, especially in the air conditioning side, and it's going to ramp the air conditioning up to make sure it can maintain 70 degrees. It's very different than conventional equipment that just comes on and goes off, comes on and goes off.
So they apply both heat and cool, right?
Yes, they do both heating and cooling, dehumidification, and it will filter the air right there at the unit. It's got very good air filtration as well.
Okay, now I'll go back to my first question. Now, is there any incentive for the VRF?
Yes,
system?
there's incentives through the Clean Heat program, which we're part of as a clean heat contractor, low carbon pathways. There's affordable programs. There's dozens of programs for heat pumps, dozens, between NYSERDA and Con Ed.
Okay. Thank
There is another reason that you should be watch out from turn off the system, especially during the winter. It's freezing. So, this is a system, if there is no heat, it's happen to be a few cold day, your pipe can freeze. So you really want to have the system. It cannot turn it off. This is
So
for freezing
because this new
boilers.
system, basically you can control through your phone. So basically the phone purpose is not to turn on and off, but just to regulate the temperature, is right?
Yes,
Okay.
yeah, the Wi-Fi capabilities now on all this equipment is fantastic. And many people are taking it. Most of it is built into the equipment now. Some of them need additional modules. You will have to download the software on your phone or your computer, but you can control all of this right from your phone.
But the purpose is not to turn on and off, but to turn.
You can control this, you can completely control this.
No, I know that, but-
100%. But yes, you're right, it's to modulate the temperature.
Yeah. Well, thank you very much. We will take more questions. I just want to be respectful for anyone's time. We're at the top of the hour. If anyone needs to leave, please feel comfortable. We're still here if you want to have more questions or until they kick us out.
Just one question. I'm in a 110-year-old landmark building, steam system, natural gas boiler, air conditioning, window units, no holes in the walls, landmark. Did I say that already? How do you tackle a building like that?
Is it one pipe system or two pipe system?
You know, I've been asked that a lot today, and I'm going to find out when I get home.
There's a big difference because if it's one pipe, sorry if I'm jumping here.
go for it.
Because if it's one pipe system, it's really old, a system, very inefficient, and there is very limited of what you can do, and you really you need to move out of this system. It's a two pipe system.
Not in the apartment. Move out of the system. Just to clarify. Okay.
No, just one.
So
Yeah.
right now, I'm doing 9 landmark buildings. And if you want to know the biggest challenge with a landmark building, it's not the building itself. It's landmarks. It's
okay.
landmarks. They're overwhelmed right now. I'm doing buildings such as the American Academy of Dramatic Arts, every building I have is over 100 years old. They all have challenges. They are built to withstand a nuclear war, many of them. So as you're drilling into buildings, you're hitting a lot of steel, some very, very aged hard concrete. The challenge also, once again, like I said earlier, is access. But if a board is on board with moving this forward, the landmark buildings are wonderful to work with because you're preserving the look of this gorgeous building and bringing it into the 21st century. So it's very, very doable.
Okay, thank you.
Is that 5 or 10?
Was that, yeah.
Okay.
That's 5? That's
10, okay.
All right,
They flashed twice. That sounded 20 to me.
Like 20, I didn't know.
Yeah, sorry.
Okay, we are in a similar building. It's not 110, but it was built in 1939. And what I have learned today is that air heat pumps might be the answer, right? If you could explain a little bit more about those, that would be great.
So conversions of older buildings, what we're looking for when we come in, obviously, is aesthetically, we are insistent with our clients that it looks good. So there's a variety of indoor pieces of equipment you can use, whether it's the wall units or the Ephoca units or ducted units that are concealed. Most of our projects, we give that option to the client. So we'll give you a base price for the building. For a 1-bedroom, it'll be a 2-zone apartment. Each will have a wall unit in the zone appropriately sized. If people want to slightly upgrade that to a ducted system, it's a little more costly, plus it takes a little bit of carpentry. We use a lot of dumbwaiters where we can. If we find a dumbwaiter to run the pipe from the base, from the floors to the roof. In many cases, we'll use a dumbwaiter plus the old steam riser, like we've done just in 205 Hicks in Brooklyn. The steam risers there was a big space behind the bathroom door. There was one in the kitchen, plus they had dumbwaiters around the building. And we were able to use those without having to core drill through the entire building. It also made it easier even for the tenant because it was taking something out of there that was not really, it was kind of unsightly. They've been painted over 1 million times. So we use the risers, the dumbwaiters, any other shafts to pipe the building. Most buildings are now asking for individual systems tied to the individual unit owner's electric panel, whether you do that in the apartment or you do that at the panel in the basement. A lot of apartments don't have a budget to put a new panel in each apartment, but the electrical upgrade in the basement affords them to have a separate breaker that could go right to the roof or out into the courtyard to their condenser. But everybody gets their own system. So once the building makes that investment, then it's up to the individual shareholder to maintain it. They usually hire us for a 1 or 2 year annual service, but you want to train everybody in the apartment on how to clean their filters, which is the #1 thing to do. And once you get past that, a lot of times you can even trade the building staff to come in and clean the filters, wash the coils, clean the outdoor units, so you can reduce your maintenance charges as well.
Okay.
Did that answer some of it?
Well, yes, but my understanding is that with the air heat pumps, that you don't have to have a system on the roof or geothermal in the ground, that there's a transfer system that goes to a if you put the heat pump in front of the window.
So that's the other subject we're talking about here today, which is sponsored by this panel, is Ephoca. It's the single monoblock unit that goes over your through-wall air conditioning hole, which is
Right.
considered a 7-inch opening in the wall,
Right.
or into your existing PTAC area.
Right.
That's Brendan and this team. Yes,
Okay, good.
but we install those. We all install this
Okay.
and distribute it.
Okay, wonderful.
It goes back to every building is different, and there's a lot of buildings where we're, especially occupied residential, we have a really, really great product for that.
Yeah.
Tom does everything in construction, so he's mentioned a few other products. At the end of the day, you want what's best for your building. You know,
Right.
whatever can be, provide what you need at the lowest installed cost usually wins anyway. So
Right.
I'm fine with him talking about everything while he's up here.
Okay.
So many of these Epicas. We do so many Epica installs that, you know, as Brendan said, what fits your need.
Gotcha.
Right?
Gotcha.
Some people don't have the ability to put a condenser anywhere. Some people have the openings.
Yeah.
It's
Well, we have the old radiators that are inset.
inset.
So that helps a lot as
Yeah.
well. I think we could put them in front of those and then have just the little bit of that transfer up to the window, the bottom of the window, right?
Right, and we were able to do that. I'm guessing you're landmarked as well, or no?
We are historical registered with
Okay,
the
yes.
state and federal, but not landmark.
Not
with the ci-
landmarks.
Yeah.
Okay, so it's every building being different. It's the type of thing that, we can come up first with the best solution and
Right.
then see if that gets approved and then
Okay,
it's always a process.
okay, great. Thank you.
Sure.
5 minutes, all right.
Okay. I have a few questions. First off, can you clear up some of the jargon for me? I'm sure some of the people don't know this either. VRF, I have no idea.
VRF is variable refrigerant flow. It is variable refrigerant flow. It is normally used for the larger heat pump systems, right? Then there's mini splits, which is the same technology. It's just smaller. So the nomenclature that the average person in the public knows is it's a mini split. That's a small unit, single fan, goes on your balcony or handles 1 or 2 or 3 rooms. Ephoca is also a heat pump. It's got inverter technology. So it's the inverter technology that really drives all the efficiencies with the heat pump products that are out there today. Everything that we're discussing up here.
Yeah, okay, I'm getting there. The other thing is PTAC. As far as I know, PTAC is your all-purpose Klingon insult for jerk or something stronger than that. But what does that mean? Pass-through air conditioning? I don't-
Package terminal air conditioning. It's package terminal air conditioning. You know when you go to a hotel
Yeah.
and you turn on the heat
Yeah.
and it goes on and off all night and you're constantly waking up?
Yeah,
That's a
it.
PTAC.
Okay.
It's a good technology from the 70s.
Yes, okay. Now I'm getting there. Okay, I live in a 6-story post-war apartment building, 96 units, standard construction, totally standard, steam heat. If we went, so there's no holes in the walls, so you won't have a heat pump going, taking air in and out. So you run refrigeration lines and take out the radiators? I got that right?
Every building is going to be different. You have to really take a look at it to see what the best approach is, because sometimes you can't do that for a lot of different reasons. Actually, they're telling us it's almost time to wrap up. So if you want, come over and chat with
Yeah,
us afterwards. I'm going to let Yohai.
Okay, what booth number?
do
What
you want to say
Yeah, I
something?
just want to say one
if
last
it's still
thing, just so
there, then
everybody
yeah.
knows. So literally within an hour, a walkthrough within an hour, and we can deliver you an idea and a feasibility on what can be done in your building. It really doesn't take that much longer. I mean, obviously the engineering and everything else does, but a basic walkthrough is probably your best bet. It's free. In an hour, you get educated. You'll have an idea on what you can do for your building, and then we can deliver you a budget.
Okay, you walked through thousands of buildings?
I've walked thousands of buildings.
You must have very strong legs.
I do.
Thank you.
All right, just want to do one just like final word from each of our esteemed panels on next steps, recommendations for next steps. And with that, we will close.
Me first?
No.
So there was a lot of information, there are a lot of decision, and you need to be proactive. It's not going to happen by themselves, and you don't want to wait until you get starting to get fine, and it will become more expensive. So, not to mention that we still have one only atmospheres, and we should care about carbon footprint, and so let's move it. Let's move the needle.
I'm gonna piggyback on Tal. We do have to be mindful of what we're putting into the atmosphere. Every time you take a boiler offline, you're taking up hundreds of buses off the street. When you take the boiler out of your building, that immediately affects the local air quality in your neighborhood.
And for me, as a representative for Ephoca, which is the equipment manufacturer, I thank you, Tom and Tal, for joining me here. We get involved, as Tom said, walking through buildings, putting together that initial, this is what makes sense for your building. Always happy to work with anyone who would be interested in learning what options are out there for their buildings.
All right, thank you everyone for joining us. And please, if you have any more questions, we're still here tearing down the booths. Happy to talk to you. Thank you.
Thank you.